With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, the question is, total kinetic energy of the molecules of the gas sample varies. Kinetic energy equal to the 7 by 4 nRT. This sample contains, and the options are, we can see, monoatomic gas, mixture of monoatomic and the diatomic gas, and the mixture of monoatomic and the polyatomic gas, and the D option we can see both 2 and 3. So we have to see which one is the correct option. So it is given that this kinetic energy is equal to 7 by 4 nRT. This where n is the number of mole. Clear? As we know, this kinetic energy is equal to degree of freedom and divided by 2 nRT. Kinetic energy is equal to F and divided by 2 nRT. This clear? Where F is what? Degree of freedom. F is degree of freedom. Clear? So this is what degree of the freedom we can see. Now, for monoatomic gas, this is equal to, for monoatomic gas, we can write this is equal to, this degree of freedom is what? Only translational degree of freedom. So this kinetic energy we can write kinetic energy for monoatomic. So we can write here monoatomic, and this is equal to 3 and divided by 2 nRT. This. And for diatomic, for this kinetic energy for diatomic we can write we can indicate by di. So this is equal to degree of freedom for diatomic is what? 5, because 3 is the translational and 2 is the rotational. So this is equal to 5 and divided by 2 and nRT. This degree of freedom. Clear? Now we can say that this is the kinetic energy that is given, that is equal to 7 by 4 nRT. So this is not a monoatomic. This is not for monoatomic and not for diatomic. It may be combination of monoatomic or diatomic, or the monoatomic or the polyatomic. It may be combination of this. So we have to check. Clear? So from here we can see that this is equal to, let us consider total number of mole is equal to n. This is n is given total number of mole, and the n1 is equal to, we can assume this n1 is equal to mole of the monoatomic. So let us consider, here is the n1. n1 is what? Number of mole of the monoatomic gas. So this is the moles of monoatomic we can consider. Monoatomic. Clear? Now total number of mole is what? N. So n minus n1 is moles of diatomic. Clear? This is the moles of diatomic. Clear? This we can consider this. Now if you find the kinetic energy of the combination of this, so we can write this kinetic energy is equal to, we can write this is equal to n. N is what? N1. Means for monoatomic we can write this is equal to n1, and this is equal to 3 and divided by 2 and r into t we can write. Clear? So this is what? 3 by 2 n1 r t. Clear? This is the kinetic energy for monoatomic. Similarly, plus this is what? For diatomic, degree of freedom is equal to what? We can write from here, this is equal to 5 and divided by 2, and this is number of mole n minus n1 into RT we can write, and this total is equal to what? 7 by 4 RT we can write, nRT. 7 by 4 nRT we can write. So this is equal to 7 by 4 nRT. This. Clear? Now this is equal to, from here we can write this RT cancel out. So from here we can write this is equal to 3 by 2 n1, 3 by 2 n1 plus we can write 5 divided by 2 into n, and we can write minus 5 by 2 n1 is equal to 7 by 4 and n we can write. Clear? Now from here we can see that this is equal to 3 by 2 and minus 5 by 2, this n1. So we can write relation between n1 and n. So from here we can write n1 is equal to 3 and divide by 4 into n, this. If we take monoatomic, this is equal to 3, number of mole is equal to what? 3 n by 4. And the diatomic is what? This is n minus n1. So for diatomic, this number of mole is equal to means n minus n1 for diatomic. Clear? For diatomic, this number of mole is equal to what? N by 4. Clear? Now in this case, this total energy is what? This kinetic energy is what? In this case, total kinetic energy is this 7 by 4 nRT. Means we can say that this case is possible when we take the number of mole of the monoatomic, that is equal to 3n by 4, and the number of mole of the diatomic, that is equal to n by 4. Similarly, this is also possible for the monoatomic and the for polyatomic. In the polyatomic, number of this we can see degree of freedom will increase, or degree of freedom will more. But these combinations also possible for this. This way we can see that mixture of the monoatomic and the polyatomics. Monoatomic degree of freedom we know that is equal to 3, and for polyatomic this degree of freedom will increase or more than this monoatomic and the diatomic. So we can say that this type of the combinations we can also form in the monoatomic and the polyatomic also. So we can say that this combinations possible in this case also. In this case, in the options, in also mixture of the monoatomic and the polyatomic also. But it is why this option is wrong. First option is wrong because this is the monoatomic. Monoatomic degree of freedom is what? 3. So this is equal to what? 3 by 2 nRT. Clear? So we can see that this is not, means first option is the incorrect, because for this is equal to 3 by 2 nRT, but this is equal to what? 7 by 4 nRT. So this is the wrong option. But yes, we can see that B mixture of the monoatomic and the diatomic, it may be possible, and the mixture of the monoatomic and the polyatomic, it is also possible. So we can write this D is the right option for this question. Clear? So we can see that this D is the both 2 and 3. This is the right option for this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.